Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Today we'll be doing hard and soft water. So rainwater is the relatively pure form of water, and but when it falls down and touches the surface of earth and flows over it, it dissolves many salts into it, thereby causing hardness. This water containing calcium and magnesium salts like hydrogen carbonate salts of calcium and magnesium, chloride salts of calcium and magnesium, and sulfate salts of calcium and magnesium, these make the water hard. So the disadvantage of hard water is it does not give lather with soap. साबुन के साथ झाग नहीं बनाता है, तो इससे जब वॉशिंग करें तो सोप बहुत वेस्ट होता है. सो हार्ड वाटर डज नॉट गिव लैदर विद सोप. वाटर free from soluble salts of calcium and magnesium is called soft water. Water that does not contain hardness causing calcium and magnesium salts is called soft water, and it gives lather with soap easily. Hard water forms scum or precipitates with soap, and soap containing sodium stearate, for example, will react with hard water to precipitate out calcium and magnesium stearate. So this is the reaction. Sodium stearate of soap reacts with the hardness causing ions calcium and magnesium to exchange these ions. Instead of sodium, this metal ion calcium or magnesium will come, which will form precipitates, and sodium ion comes into the water. So because of this, the soap, which was otherwise to be used as a cleansing agent, is wasted in removing hardness. Here the M is calcium or magnesium. So this hard water is unsuitable for laundry. It is unsuitable for industrial purposes. In industries, boilers are used, and this hard water is not suitable for boilers because of deposition of salts in the form of scales in the boiler. This reduces the efficiency of boiler, and because of uneven heating, because of deposition of steels on the bottom of the boiler, there is a risk of the boiler being broken, and accidents may be caused because of it. So we can divide hardness into two classes. We can classify them into temporary hardness and permanent hardness. Temporary hardness is caused by hydrogen carbonates of magnesium and calcium. Magnesium bicarbonate will cause temporary hardness. Calcium bicarbonate will cause temporary hardness. It can be removed by boiling. So if we heat water, the magnesium bicarbonate present in it, which is causing temporary hardness, it will get precipitated into magnesium hydroxide, which is insoluble, and gas, carbon dioxide, will be formed. So on filtration, we can remove temporary hardness from water and make water soft water. Similarly, calcium bicarbonate on heating changes to calcium carbonate, which also precipitates out. Along with it, water and carbon dioxide are formed. Now, magnesium bicarbonate forms magnesium hydroxide and not magnesium carbonate, because solubility product of magnesium hydroxide is higher as compared to magnesium carbonate. So on heating with or on boiling, the temporary hardness causing agents get converted into precipitates and can be filtered, and water can be made soft. So the filtrate will be soft water. We boil water and then we filter it. The precipitates remain on the top of the filter paper, and the solution that percolates contains soft water. Second method to remove temporary hardness is Clark's method. In this method, we add a calculated amount of lime or calcium hydroxide. So the hardness causing agents, calcium bicarbonate or magnesium bicarbonate, will react with this lime to form precipitates of calcium carbonate or magnesium hydroxide along with calcium carbonate in case of magnesium bicarbonate. And then again on filtration we get soft water. In comparison, permanent hardness is because of chlorides and sulfates of magnesium and calcium. It is not removed by boiling. The methods that can be used for removing permanent hardness are: number one, treatment with washing soda or sodium carbonate. So the chlorides or sulfates will react with sodium carbonate to form precipitates which can be removed along with sodium salts, which does not cause hardness. Second method is Calgon's method. Cal means calcium, gon. So sodium hexametaphosphate is also called commercially Calgon, means responsible for removal of calcium. So when this sodium hexametaphosphate is added to hard water, it decomposes into sodium ions and this complex ion, which can react with this hardness causing ion, calcium or magnesium, to form this complex ion. So because the metal, the hardness causing agent, remains in the coordinate complex form, it remains in the passive form, so its effect as hardness is removed. Then we also have ion exchange method. In this method is also called zeolite permutate process. Hydrated aluminum silicate is called zeolite or permutate, and for the sake of simplicity, this sodium aluminum silicate, we just name this portion as Z. So sodium zeolite, it can be written as sodium zeolite, so the reaction becomes simpler. When we put this resin in hard water, the hardness causing ion will get exchanged in the zeolite with sodium. So the hardness causing ion gets attached to the resin, and water will contain now sodium, which does not cause hardness. So hard water can be made into soft water. Once this hardness removing zeolite is exhausted, it can be regenerated by brine solution. Sodium chloride will again exchange ions with it to form again sodium zeolite, and it can be again used for softening hard water. Synthetic resin method. Nowadays hard water is often using synthetic cation exchanges. This method is more efficient than zeolite process. Cation exchange resin will contain large organic molecules and sulfonic acid group. Now these are water insoluble. This cation exchanger is then changed to sodium resin complex by treating with sodium chloride, and this sodium resin complex can remove hardness causing ions by this reaction. Hardness causing ion will get exchanged. Instead of sodium will come into water, and once this resin is exhausted, it can be regenerated by adding aqueous NaCl solution. Pure demineralized water free from all soluble mineral salts is obtained by passing water successfully through a cation exchanger in the H+ form and anion exchanger in the OH negative form resins. So hard water is poured from the top. The cation exchanger bed is present over here. The hardness will get incorporated into the bed, and the hydrogen ions will come into water. This water will not contain any calcium or magnesium ion. This is again pumped to an anion exchanger tank, again poured from top. The anion exchanger will this time exchange anionic hardness causing agents like carbonate, bicarbonate, sulfates or chlorides, and these ions will get trapped over here, and water and this will release OH negative ions into the water. So the water which comes out is soft water and does not contain any hardness causing cation or anion. The reactions are in the cation exchanger. This is the resin, and the metal ions will be exchanged, calcium or magnesium ions will be exchanged to get incorporated into the resin, and H plus goes into water. Similarly, in the anion exchange resin, this it will first get converted into and this will exchange the hardness causing anionic ions with OH negative ions. So OH negative will come into water. After cation exchanger is used, water becomes acidic, but after passing it through the anion exchanger, the OH negative ions that are introduced will again neutralize the acidic water back into soft neutral water. So that's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.